Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on sample space diagrams. If you need any extra help on sample space diagrams, if you go to Corbettmaths and go to the videos and worksheets section, and scroll down to video number 246, there's a dedicated video tutorial there on sample space diagrams. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number one. Question number one says, Arthur flips a coin and rolls an ordinary six-sided dice. And we've been asked to complete the table to show all the possible outcomes. So if we have a look here, he could get a tail on the coin and he could get a 1 on the dice, and that'll be a tail and a 1. He could get a tail on the coin and a 2 on the dice, and that'll be a tail and a 2, and so on. So our next one will be a tail and a 3, so a tail and a 3, then a tail and a 4, a tail and a 5, and a tail and a 6. So we've now completed all the outcomes with a tail. Now let's have a look at the heads. He could get a head on the coin and a 1, so that'll be a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, and a head and a 6. And they're the 12 possible outcomes. Okay, let's have a look at our next part, part B. So part B says find the probability of a tail and a 6. So if we have a look here, we've got 12 possible outcomes. So we're going to put 12 on the denominator. And a tail and a 6. Well, a tail and a 6 is this outcome here. So there's only one option that is a tail and a 6 is this one. So it's going to be 1 out of the 12. So 1/12. So the probability of getting a tail and a 6 would be 1 out of 12, or 1/12. So 1/12. And that's it. Okay, let's look at the next part, part C. So part C says find the probability of a head and a number greater than 2. So that would be a head and a 3, a head and a 4, a head and a 5, and a head and a 6. We're not going to include a head and a 2 because the number's got to be greater than 2. So there's 4 outcomes there that would work: a head and a 3, a head and a 4, a head and a 5, and a head and a 6. And that's 4 out of the 12. So it means the probability of one of those outcomes would be 4 out of 12, or 4/12. And that's equal to 4/12. So we could write 4/12 here, or we could cancel it down. Both of these numbers are divisible by 4, so we could just divide both of them by 4 to get 1/3. So we could write down 4/12 there. We weren't asked to cancel it down, so we could write 4/12, and if you wrote 4/12, that's perfectly fine. But I've decided to cancel it down. I've halved them both to get 2/6, and I've halved them again to get 1/3, or I've just divided both of them by 4 to get 1/3. Okay, let's have a look at our next part, part D. So part D says find the probability of a tail and a square number. So our square numbers are, well, 1 times 1 is equal to 1, 2 times 2 is equal to 4, and 3 times 3 is equal to 9. So that's not going to be an option in terms of our outcomes because the dice only goes up to 6. So in terms of a tail and a square number, that would be a tail and a 1 and a tail and a 4. There's 2 possible outcomes that would work. A tail and a 1 would be this outcome here, and a tail and a 4 would be this outcome here. So there's 2 possible outcomes that would work out of the 12. So that means the probability will be 2 out of 12, or 2/12. So 2/12. And we could write that down as our answer, 2/12, or we could divide both of these by 2 to simplify it to be 1/6. And that's it. So that means the probability of getting a tail and a square number would be 2/12, or 1/6. And that's it. Okay, let's look at our next question, question number 2. Okay, so let's have a look at our next question, question number 2. So question number 2 says, Jordan is playing a game with a fair 4-section spinner. So it's a fair 4-section spinner with the sections 1, 2, 3, and 4. They're labelled 1, 2, 3, and 4. And a fair coin with heads and tails. And he flips the coin and spins the spinner. And one possible outcome is a head and a 1. And that can be written as, and then we've got in brackets, H1. And then part A says, list all the possible outcomes below. So we've got a head and a 1. So then we've got a head and a 2, a head and a 3, a head and a 4. So there are all the outcomes with a head. Now let's have a look at tails. So then we've got a tail and a 1, a tail and a 2, a tail and a 3, and a tail and a 4. So there are all the possible outcomes. And then part A says find the probability of a tail and a 3. So here we've got obviously all the outcomes, and there's 8 outcomes altogether. 1, 2, 3, 4, 5, 6, 7, 8. So it means that there's 8 possible outcomes. So we're going to put 8 on the denominator. And a tail and a 3. Well, there's only one outcome that's a tail and a 3, and that's this one, a tail and a 3. So it's going to be 1 out of 8, or 1/8. And then part C says find the probability of a head and an odd number. So that would be a head and a 1, or a head and a 3. There are possible outcomes, a head and a 1, and a head and a 3. So that outcome there, and that outcome there. So that's a head and an odd number, a head and an odd number. So that's 2 out of 8, or 2/8. So let's write that down, 2 out of 8. And then actually we could write 2/8 if we wanted to. I'm going to cancel it down, so I'm going to divide both of those by 2 to get a quarter. So the probability of a head and an odd number would be 1/4, or you could write 2/8. And that's it. Okay, let's have a look at our next question, question number 3. So question number 3 says, Rebecca's got 2 bags containing counters. So she's got 2 bags that contain counters, and we've got diagrams of them here. And each counter is labelled with a number. And as you can see, they're all labelled with numbers. And Rebecca's going to pick a counter at random from bag A, and then she's going to pick a counter at random from bag B. And we've been asked to complete the table to show all the possible outcomes. So for instance, she could pick from bag A, I'll just scroll up here. Just scroll up a bit here. In bag A, she could pick a counter 1, and then from bag B, the counter 1. In bag A, she could pick the counter 1, and then in bag B, the counter 5. So that's that outcome. In terms of this outcome here, she could pick a 1 from bag A and a 7 from bag B. So that'd be a 1 and a 7. She could pick a 3 from bag A and a 1 from bag B. So that's that outcome there. Our next one, that would be a 3 from bag A and a 5 from bag B. She could pick a 3 from bag A and a 7 from bag B. She could pick a 4 from bag A and she could pick a 1 from bag B. She could pick a 4 from bag A and a 5 from bag B. And she could also pick a 4 from bag A and a 7 from bag B. So there are all the outcomes with 4 from bag A. Now let's look at 5. She could pick a 5 from bag A and a 1 from bag B. She could pick a 5 from bag A and a 5 from bag B. And finally, she could pick a 5 from bag A and she could pick a 7 from bag B. So they're all the possible outcomes. There's 3, 6, 9, 12 of them, or 4 times 3. There's 12 outcomes there. Okay, so that's part A done to complete the table. Part B. Part B says find the probability that Rebecca picks a 1 from bag A and a 7 from bag B. So a 1 from bag A and a 7 from bag B. So that's this outcome here. So it's this one outcome out of the 12 of them. So the probability will be 1/12. And that's it. Okay, part C. Part C says find the probability that Rebecca picks counters with the same number on them from each bag. So we're looking for outcomes that have got the same number. So that'd be this outcome here, a 1 and a 1. Or we've got a 5 and a 5 here. And that's it. There's 2 possible outcomes out of the 12. So that'll be 2 12ths. So 2 12ths. And we could cancel that down. Both of these numbers are divisible by 2. So I'm going to divide both of them by 2 to get 1/6. Now we could leave our answer as 2 12ths because we weren't asked to cancel it down, but I just have to give us 1/6. And that's it. That's that question done. Okay, let's look at our next question, question number 4. Okay, so question number 4. Question number 4 says 2 bags, bag 1 and bag 2, contain 3 counters that are equal size. So we've got these 3 counters that are equal size. And in bag 1, the counters are labelled 1, 2 and 3. And we can see that. And in bag 2, the counters are labelled 1, 2 and 4. And a counter is drawn at random from bag 1 and a counter is drawn at random from bag 2. And the 2 counters, or the 2 numbers, are added together to give a score. So for instance, if I was to take a 1 from this bag and a 1 from this bag, we'd add them together to give us a score of 2. Or we could take a 3 from this bag and a 2 from this bag and we'd add them together to get a 5, and so on. And we've been asked to complete the table below to show the possible scores. So here we've got bag 1. We could take a 1 from bag 1 and a 1 from bag 2, and we could add them together to get a 2. We could get a 2 from bag 1 and a 1 from bag 2 and add them together. 2 plus 1 is equal to 3, and so on. So to complete this table, we just need to add together the numbers on the counters. So we would do 3 plus 1, that's equal to 4. 1 plus 2, that's equal to 3. 2 plus 2, that's equal to 4. 3 plus 2, that's equal to 5. 1 plus 4, that's equal to 5. 2 plus 4, that's equal to 6. And finally, 3 plus 4 is equal to 7. So they're all the possible scores that we could get if we were doing this. Okay, so part B. Part B says find the probability of scoring a 4. So let's have a look at our table. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 different things that can happen. We can get a 1 and a 1, a 2 and a 1, and so on. So there's 9 possible outcomes. So let's put a 9 on the denominator. And the probability of scoring a 4, well, there's 1, 2 4s. So it's 2 out of the 9, so 2 ninths. So the probability of scoring a 4 will be 2 ninths. And then part C. Part C says find the probability of scoring less than 5. So less than 5. Okay, 2 is less than 5. 3 is less than 5. 4 is less than 5. 3 is less than 5. 4 is less than 5. 5 isn't less than 5, it's equal to 5. 5 is not less than 5. 6 is not less than 5, and neither 7. So in terms of probability of getting a number that's less than 5, there's 9 possible options, so let's put 9 on the denominator. And in terms of the numbers that are less than 5, there's going to be 1, 2, 3, 4, 5 of them. So that's 5 ninths. So the probability of getting a score that is less than 5 will be 5 ninths. And that's it. Let's write that down. 5 ninths. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 5. So question number 5 says 2 fair 6-sided dice are rolled. So we've got 2 dice that are rolled and the numbers on the dice are multiplied together to give a score. And part A says complete the table to show all the possible scores. So for instance, if we got a 2 and a 3, like shown here, 2 times 3 is equal to 6. So that would be a possible score that we could get. So let's have a look at our sample space diagram because that sets it out nicely for us. We could get a 1 on dice 1 and a 1 on dice 2, and 1 times 1 is equal to 1. We could get a 2 on dice 1 and a 1 on dice 2, and 2 times 1 is equal to 2. 3 times 1 is equal to 3. 4 times 1 is equal to 4. 5 times 1 is equal to 5. And 6 times 1 is equal to 6. Okay, if we got a 1 on dice 1 and a 2 on dice 2, 1 times 2 is equal to 2. If we got a 2 on dice 1 and a 2 on dice 2, 2 times 2 is equal to 4. And that's it, I filled out all the possible scores. Obviously the largest one being 36 because 6 times 6 is 36. Okay, and then part B. Part B says find the probability of scoring a 12. So in terms of this question, to find the probability, well, there's 36 possible outcomes because we've got 6 rows of 6. So the denominator is going to be 36 because we've written 36 scores into our table. So it's out of 36. And in terms of the probability of scoring a 12, let's look for 12s in our table. So there's a 12, 1. There's another 12, 2. There's another 12, 3, and there's another 12, 4. So there's 4 different 12s, so it's going to be 4 out of 36, or 4 36. So we could leave our answer like that if we wanted to and write down 4 36. I'm going to cancel this down. We could divide both of those by 2 to get 2 18ths, and we could divide by 2 again to get 1 9th. So the probability of getting a 12 would be 1 9th, or 2 18ths, or 4 36. Okay, let's have a look at our next part, part C. Part C says find the probability of scoring a 10 or more. So we want any number that's 10 or more, so 10 or more. Okay, so I've boxed all the numbers that are 10 or more. Let's just count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's 19 out of the 36. So the probability of scoring a 10 or more will be 19 36. And that's it. Okay, and then part D. Part D says find the probability of an even number. So let's go back up to our sample space diagram and see how many even numbers are there. Okay, so let's go back up to our sample space diagram and we're looking for any even number. So in terms of the even numbers, this whole row is even. So this whole row is even. That's even, 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 and even. So is this row, because obviously we're doing 4 times certain numbers. And then this row as well, they're all even as well. And then we've got an even numbers here, here, and here, 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 and here, and finally here, here, and here. So let's count them and see how many even numbers there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there's 27 even numbers out of the 36. So the probability of an even number will be 27 36. And we could leave our answer like that if we wanted to. Both of these numbers, they were divisible by 9, so we could divide both of them by 9 to get 3/4, because 27 divided by 9 is 3, and 36 divided by 9 is equal to 4. So the probability of getting an even number is 3/4, or 27 36. And that's it. Okay, let's have a look at our next question, question number 6. So question number 6, it says Jordan is playing a game and he's got this spinner and the fair coin, and he spins the spinner and flips the coin. And if the coin lands on heads, his score is going to be 1 more than the number on the spinner. And if his coin lands in tails, his score is going to be double the number on the spinner. And part A says complete the table to show all the possible scores that Jordan could get. So if it lands on heads, it's 1 more than what's shown on the spinner, and if it lands on tails, it's double what's shown on the spinner. So let's go to our table, and let's start off with heads. If it's heads, it's 1 more than what's shown on the spinner, so it's going to be 1 more than what's shown on the spinner. So 1 more than 1 would be a 2. If it landed on a head and a 2, we would add 1 more to that, so that would be 3. 1 more than 3 would be 4, and 1 more than 4 would be 5. So if it lands on heads, it's 1 more than what's shown on the spinner. But if it lands on tails, his score is going to be double what's shown on the spinner. So if we double the 1, that'll be 2. If we double the 2, that's 4. If we double 3, that's 6. And if we double 4, that's 8. So they're the possible scores that he could get. Okay, and then part B. Part B says, find the probability that Jordan gets a score of a 4. So if we have a look at the table, there's 1, 2, 3, 4, 5, 6, 7, 8 different answers in our sample space diagram. So let's put 8 on the denominator. And in terms of a 4, there's 2 4s. So it's going to be 2 out of 8. And that means the probability of Jordan getting a 4 would be 2/8. Now we could cancel this down. We could divide both of these by 2, and that's equal to 1/4. So the probability of him scoring a 4 would be 1/4, or you could leave it as 2/8 if you wanted to. Okay, our next part says find the probability that Jordan gets a score that is 5 or more. So 5 or more, well, that's 5. And that's more than 5, and that's more than 5. And these options here, they're not 5 or more, they're actually going to be less than 5 there. So in terms of 5 or more, there's 3 out of the 8, so it's going to be 3 ifs. So the probability of Jordan getting a 5 or more will be 3 ifs. Okay, so our next one. So the next one says find the probability that Jordan gets a score that is a prime number. So a prime number, let's write down our prime number. So prime numbers are numbers that have only got two factors, 1 and itself. So the first prime number will be 2, and then 3, and then 5, and then 7. And then the next one's 11, but if we actually have a look here, none of the scores go up as high as that. So actually the prime numbers that we're looking for are 2, 3, 5, or 7. So let's look for 2, 3, 5, and 7. So I'm just going to get rid of the ticks that we had for the previous part. Okay, so 2, well, we've got a 2 here and a 2 here. 3, there's a 3 there. 5, there's a 5 there. And 7, no, there's no 7s. So in terms of the probability of a prime number, that's going to be 1, 2, 3, 4 out of 8. So that would be 4 ifs. So 4 ifs. And both of those numbers are divisible by 4, so we can actually cancel that down to be 1/2. And that's it. So that means our answer is a half. Or you could write, if you wanted to, 4 ifs, but I've just written a half here. And that's it. Okay, so let's have a look at our next question, question number 7. So question number 7 says, spinner 1 has got 4 equal sections labelled 1, 3, 4, and 5, and spinner 2 has got 3 equal sections labelled 5, 6, and 7. And each spinner is spun once, so they're going to spin both spinners once, and the numbers are added together to get a score. And part A says, complete the table, the sample space diagram, to show all the possible scores. So we could get a 1 on spinner 1 and a 5 on spinner 2, and we're adding them together, added together, so 1 plus 5 is equal to 6. We could get a 3 on spinner 1 and a 5 on spinner 2, and we add them together, we get 8, and so on. Let's carry on. 4 plus 5 is equal to 9, 10, 7, 9, 10, 11, 8, 10, 11, and 12. And that's it, they're the possible scores. And part B says find the probability of scoring an 8. So we've got 4, 8, 12 different numbers in our table. So we've got 12 different outcomes. And we've got find the probability of scoring an 8. So there's 1, 2, 8. So it's 2 out of 12. So 2 out of 12. And that could be cancelled down. You could leave it like that if you wanted to and write 2 12s because we weren't asked to cancel it down. Or in this case, I'm going to half both of those to get 1/6. So the probability of scoring an 8 will be 1/6. Okay, part C. Okay, part C. Part C says find the probability of scoring an odd number. So let's circle the odd numbers. 6, no. 8, no. 9, yes, that's 1. And then 7, 9, 11, and 11. So we've got 1, 2, 3, 4, 5 odd numbers out of the 12. So that's going to be 5 out of 12 or 5 12ths. And that can't be cancelled down. So the probability of scoring an odd number is 5 12ths. And let's just check, are there 7 even numbers? 1, 2, 3, 4, 5, 6, 7. That's right. And that's it. So let's have a look at our next question. So question number 8 says Anna has 2 fair spinners. We've got spinner A and spinner B, and she spins both spinners and multiplies the numbers to get a score. And part A says complete the table to show all the possible scores. So here we've got spinner A and spinner B, and it says that the 2 scores are multiplied together. She multiplies the scores together, and they're all the possible scores that Anna could get. And then we're told that Anna says that it is more likely that her score will be a prime number than a square number. Is Anna correct? Explain your answer. Okay, so let's have a look at our sample space diagram, and let's start off in blue, taking any of the prime numbers. So 2's prime, let's take that. 3's prime, take that. And they're the only prime numbers in this grid, 2 and 3, and that's it. Okay, now let's look at the square numbers. So let's consider the square numbers in green. So the square numbers are, well, 1 times 1 is equal to 1, 2 times 2 is equal to 4, 3 times 3 is equal to 9, 16, 25, 36, 49, 64, 81, 100. You should know those off by heart. 11 times 11, 121. 12 times 12, 144. 13 times 13 is a calculator question anyway, 169. And 14 times 14 is 196. And that covers all the numbers in this grid. So let's circle any of the square numbers. So 4 square, 9 square, 16 square, and then 36 is square, 64 is square, 36 is square, And that's it. There are all the square numbers. There's 1, 2, 3, 4, 5, 6 square numbers in that grid. So we've been asked, is Anna correct? Anna says it's more likely she's going to get a prime number than a square number. So you could just explain there's only 2 prime numbers and the 6 square numbers. So it's more likely she's going to get a square number than a prime number. So the probability of a prime number, is equal to 2. So let's just check what the denominator is here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 rows of 4. So the probability of getting a prime number is 2/16. And the probability of getting a square number, the probability of a square number will be equal to 1, 2, 3, 4, 5, 6, 6/16. And as you can see, it's more likely to get a square number than a prime number because 6/16 is bigger than 2/16. So let's just explain that. And that's it. Just explain that no, the probability for a square number is greater than the probability of a prime number. And that's it. Now you could, as I said, mention just that in the grid there's 6 square numbers and 2 prime numbers. So therefore it's more likely that Anna's going to get a square number than a prime number. But I've just looked at the probabilities. Okay, let's look at our next question. Okay, so question number 9. Question number 9 says 2 bags, 1 and 2, each contain counters that are equal size. So we've got these counters. We were told that in bag 1 they contain a pink, a green and a yellow counter. P, G and Y. And bag 2 contains counters that are labelled 2, 3, 4 and 5. And a counter is drawn at random from bag 1 and a counter is drawn at random from bag 2. And if the counter in bag 1 is pink, the number on the counter from bag 2 is doubled. If the counter from bag 1 is green, 1 is added to the number of the counter from bag 2. And if the counter from bag 1 is yellow, the number on the counter from bag 2 stays the same. And we've been asked to show that on the sample space diagram. So let's do that. Okay, so let's have a look at our sample space diagram. So we've got bag 1, pink, green and yellow, and bag 2 we've got 2, 3, 4 and 5. So if a pink is selected from bag 1, the number on the counter is doubled. So if we get a pink, that's going to double these numbers. So it's going to be 4, 6, 8 and 10. Okay, if the counter from bag 1 is green, 1 is added to the number on the counter from bag 2, so 1's going to be added to these numbers. So if we get a green, we're going to add 1 to these numbers. That'll be 3, 4, 5 and 6. And then finally, if the counter from bag 1 is yellow, the number on the counter stays the same, so it's going to be 2, 3, 4 and 5. So we've completed our sample space diagram. And then part B says find the probability of scoring a multiple of 3. So a multiple of 3, so that's 3, 6, 9, 12 and so on. So a multiple of 3, let's circle the multiples of 3. So 3 is a multiple of 3, 6 is a multiple of 3, 3 is a multiple of 3, and 6 is a multiple of 3. So out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers, so there's 12 numbers, so let's put 12 in the denominator. 1, 2, 3, 4 of them are multiples of 3. So it's going to be 4 12ths, and you could just write down 4 12ths as your final answer. But I'm going to divide both of these by 4, so that'll give us that's equal to 1 over 3, or 1/3. So the probability of getting a multiple of 3 is 1/3, and that's it. Okay, so question number 10. Question number 10 says Phil uses 2 fair spinners in the game. So we've got spinner 1 and spinner 2. And he spins these spinners and the 2 numbers are multiplied together. And part A says complete the table to show the possible scores. So we've got spinner 1, 0, 2 and 3. And spinner 2, we've got a 1, a 3 and a 5. So they're all the possible scores that he can get. And then that's part A done. And then it says that Phil says the probability that he scores an even number is a half. Explain why Phil is incorrect. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. So we're going to have 9 on the denominator. I want to find the probability of an even. Well, actually, already we can see it's not going to be a half, because for it to be a half, there'd have to be 4.5 even numbers out of 9. So with 9 on the denominator, we're not going to get it to be equal to a half. But let's find out the probability of an even number. So an even score, 0 is even. So that's 1, 2, 3, 4, 5, 6. There's 6 even numbers in that grid. There's 1, 2, 3, 4, 5, 6 even numbers out of the 9, because 3, 9 and 15 are odd and the rest are even. So it's going to be 6 out of the 9 outcomes. So the probability of getting an even number is 6 out of 9. And we could leave it like that if we wanted to, and we know that's not equal to a half. Or we could cancel it down. Both of these numbers are divisible by 3. 6 divided by 3 is 2. And 9 divided by 3 is 3. So the probability of an even number, an even score, is 2/3, not a half. And that's it. I've just said the probability of getting an even score is 2/3 or 6/9, which is not a half. And that's it. Okay, let's look at our next question. Okay, so question number 11. Question number 11 says two fair six-sided dice are rolled, and the score is the difference between the numbers on the dice. So for instance, if we rolled a 1 and a 1, the difference between them is 0. If we rolled a 2 and a 1, the difference between them is equal to 1. So we're going to take away the scores on the dice. So if we got a 3 and a 1, 3 take away 1 is equal to 2, 4 take away 1 is equal to 3, 5 take away 1 is equal to 4, and 6 take away 1 is equal to 5. So we filled out our table showing the difference between the scores on the dice. Okay, part B. Part B says find the probability of scoring a 2. So there's 36 different outcomes in this table. There's 6 rows of 6, or you could count them. There's 36 on the denominator. There's 36, so we're going to put 36 on the denominator. And there's probability of scoring a 2. Let's count the number of 2's in the table. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 2's in this table. So it's going to be 8 out of 36. So that means the probability of scoring a 2 would be 8/36. Now we could cancel this down. We could divide both of these by 2 to get that's equal to 4 8 times. And we could actually divide by 2 again to get that's equal to 2/9. And I would probably do that. I'd probably write down the probability of getting a 2 to be 2/9. But in this question, it didn't say you had to cancel it down. So like all the other ones we've looked at before, you could leave it as 8/36. And that's it. Okay, next one, part C. Part C says find the probability of scoring a number less than 3. So a number less than 3. So a number less than 3, that's going to be a 0, a 1, or a 2. So they're all less than 3. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's going to be 24 out of the 36. So 24/36. And that's it. And we could cancel that down if we wanted to. So both of these numbers are divisible by 12. So dividing them both by 12 would be 2/3. So the probability of scoring a number less than 3 would be 2/3, or 24/36. And that's it. Okay, so let's have a look at our next question, question number 12. So question number 12 says a fair dice is numbered 1 to 6. So it's a fair dice, and the dice is rolled twice. Draw a sample space diagram to show the possible outcomes. So let's do that. Okay, so I've started to create a sample space diagram. We've got the first roll going down vertically like so. So on the first roll, we could get a 1, a 2, a 3, a 4, a 5, or a 6. And then going across horizontally, we've got the second roll. So for instance, here we could get a 1 and then a 1. We could get a 1 and then a 2. We could get a 1 and then a 3, a 1 and then a 4, and so on. So let's fill out all those outcomes now. Okay, so here we've got all the possible outcomes, and then where the part B says work out the probability that the number obtained in the first roll is more than double the score in the second roll. So we're looking for any outcome where the number in the first roll is more than double what is scored in the second roll. So we want to find outcomes where the number in the first roll is more than double what's on the second roll. So for instance, we could have a 3 and a 1, because the first roll is a 3, the second roll is a 1, and 3 is more than double 1. 4 and a 1, that would work as well, because if we double 1 we get 2, and 4 is more than double that. 5 and 1 would work as well, and 6 and 1. So 3 and 1, 4 and 1, 5 and 1, and 6 and 1. Here the number obtained in the first roll is more than double what's obtained in the second roll, because they're all more than double this number. We could also have a 5 and a 2 and a 6 and a 2, because the number in the first roll is more than double the number in the second roll, because if we double 2 we get 4, and 5 is more than that, and 6 is more than that as well. And that's it, there are all the possible outcomes, because if we had a 3 on the second roll, if we want to find a number in the first roll that's more than double that, double 3 is 6, and more than that would be then 7, but we can't get that. So the possible outcomes will be a 3 and a 1, so a 3 and a 1, that would work, a 4 and a 1, a 5 and a 1, and a 6 and a 1. And in all these cases, all these outcomes, the number in the first roll is more than double what we get in the second roll. Also a 5 and a 2 would work, and a 6 and a 2. They're all the possible outcomes that would work. So out of the 36 possible outcomes, 1, 2, 3, 4, 5, 6 of them would work. So the probability that the number rolled in the first dice is more than double the number scored in the second dice, that's going to be 6 out of 36, because there's 6 options that work out of the 36. And that's it. You could cancel that down if you wanted to, and they're both divisible by 6. So 6 divided by 6 is 1, and 36 divided by 6 is 6. So that's it. Okay, let's look at our next question. Okay, so question number 13. Question number 13 says James has organised a game to raise money for charity at a local fair, and he rolls an ordinary 6-sided dice. So he's going to roll a dice and he flips a fair coin. And if the coin lands on heads, so if we get heads, the number in the dice is squared. But if the coin lands on tails, like shown here, the number in the dice is cubed. and a person pays 50p to play, and if they score above 30, they win £1. And the game's played 450 times, and the question says how much money should James raise for charity? So let's draw a sample space diagram to begin with. So here we've got our sample space diagram. We've got the dice going across horizontally and the coin here vertically. And if we go back up, we're told that if the coin lands on heads, so if it lands on heads, the number on the dice is squared. So if we square these numbers, we can see if it lands on heads, all the numbers on the dice here would be squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. So for instance, if someone gets a head and a 6, because it's a head, we square the 6, and that's 36, and so on. And if the coin lands on tails, the number in the dice is cubed. So 1 cubed is 1, 2 cubed, 2 times 2 times 2 is 8, 3 cubed, so 3 cubed is 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. 4 cubed is equal to 4 times 4 is 16, times 4 is 64. 5 cubed is equal to 5 times 5 is 25, times 5 is equal to 125. And finally 6 cubed. 6 times 6 is 36, and then we need to times that by 6, so 36 times 6. And I'm going to work that one out. It's 36 times 6, 6 times 6 is equal to 36, so put a 6 down, carry a 3. 6 times 3 is 18, plus 3 is 21, so that's 216. So we've got all the numbers here in the sample space diagram, and we're told that if someone scores above 30, they win £1. So let's find the probability that the number is bigger than 30. So the probability of over 30. So over 30. So in the table, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. So 12 is on the denominator. And over 30, that's 1, 2, 3, 4 of them. So the probability of getting over 30 will be 4 out of 12, and that can cancel down. Both of those numbers are divisible by 4, so that's going to be 1/3. So the probability that someone gets over 30 is 1/3. So in other words, if the game's played 3 times, one person should win. So then we're told the game is played 450 times. So because the probability of winning is 1/3, if we do 1/3 of 450, we can see how many winners there should be. Now obviously it may not be exactly this number, because the question says how much money should James raise for charity. So if we do 450 divided by 3 to get 1/3 of something, you divide it by 3. So how many 3s go into 4? That's 1, remainder 1. How many 3s go into 15? That's 5. And how many 3s go into 0? That's 0. So that's 150. So there should be 150 winners. So that's how many winners there should be. Now obviously there may be less or there may be more. Now each winner wins £1. So that means that in prize money, James should give out £150. So because 150 times £1 is equal to £150. That's how much money should be given out to the winners. So we've worked out how much money James should give out, £150, and we now need to see how much money he's going to take in. So the game's played 450 times, and each person pays 50p to play. So that means that if we do 450 times 50p, we can see how much money James is going to receive. So let's work that out. So we need to do So we're going to do 450 multiplied by 50p. So let's work this out. Now, if we had 450 50p's, 2 50p's make £1. So if we divide this by 2, we can see how much money that would be in pounds, and that would be equal to £225. Or another way to do it is to take our 450 and multiply that by 50 and see what we get. To multiply by this, we're going to put a 0 down and then times by 5. So 5 times 0 is 0. 5 times 5 is 25, put a 5 down and carry a 2. And 5 times 4 is 20, plus 2 is 22. So that's 22,500 pence, or £225. So James is going to take in £225. He's going to be given away, should be given away £150 in prizes. Now, maybe slightly more, maybe slightly less, but the question is how much money should he raise for charity? So he should raise, if it goes as expected, he should raise, if we work to take this away, we see how much profit he gets, how much is going to go to charity. So 5 take away 0 is equal to 5. 2 take away 5, let's borrow, so that's now 12 take away 5, that's 7. And 1 take away 1 is 0. So he should raise £75 for charity. And that's it. Okay, let's have a look at our last question, question number 14. So question number 14 says, George has 3 cards, each with an algebraic expression written on it. So they've got 3 algebraic expressions on these cards. We've got x plus 1, 5x, and x cubed. So this one means add 1 to whatever number x is. This one's saying take the number that x is and times it by 5. And this one's saying cube whatever x is. And he picks one of the cards at random, so he's going to pick one of these cards at random, and then he spins his spinner. And then it says that George substitutes the number that's shown on the spinner into the algebraic expression. So for instance, if this lands on 1 and he lands on x plus 1, we're going to do 1 plus 1 is equal to 2. Or if he picked the card 5x and it landed on 1, we do 5 times 1, which is equal to 5. And if he picks this one and it lands on 1, we're going to do 1 cubed, which is 1, and so on. So we've been asked to complete the table to show the possible results. So we've got here all the values for x, what the spinner lands on, and then what's shown on the card. So in this case, we're going to substitute all these values into this expression. So we're going to do 1 plus 1, we're going to do 3 plus 1, we're going to do 5 plus 1, and we're going to do 6 plus 1. So it means we're going to add 1 to each of these. So we're going to get 2, 4, 6, and 7. Now here, if he was to pick this card at random and then he lands on a 1, well, 5 times x, 5 times 1 is equal to 5. If he picks this card and it lands on a 3, he's going to do 5 times 3, which is equal to 15. If he picks this card at random and he lands on a 5, you can do 5 times x, so 5 times 5 is equal to 25. And if he picks this card at random and the spinner lands on a 6, we're going to do 5 times 6 is equal to 30. So we filled out the first 2 rows. Now we just need to fill out the last row. So if he picks this card at random and he gets a 1, we're going to do 1 cubed, which is equal to 1, because 1 times 1 times 1 is 1. And this is a calculator question, so feel free to type in 1 cubed on the calculator, and 3 cubed, and 5 cubed, and 6 cubed. And they would be equal to 27, 125, and 216. So we've got our values in our table, and then the question says George picks a card at random. So he's going to pick one of the cards at random and he spins the spinner a total of 300 times. So he does that 300 times. And the question says estimate how many times George should get an odd number. So how many times should he get an odd result? So obviously he's going to do this 300 times. So we want to find out how many times he expects to get a certain outcome. And to do that, what we do is we take the probability of that outcome happening and we multiply it by the number of trials, or the number of times it's carried out. So let's find the probability of an odd, the probability of an odd. So let's look at our table. There's 12 outcomes, so it's going to be out of 12. And let's find out how many odd numbers there are, how many odd results there are. So it's going to be 1, 2, 3, 4, 5, 6, 7. There's 7 odd results. So the probability of getting an odd would be 7 twelfths. Now he does this 300 times. So if we take the probability, the 7 twelfths, and we multiply that by 300, that'll tell us how many times he would expect to get an odd result. So on our calculator, we can just do 7 twelfths times 300, and that's equal to 175. Or you could do, if this was a non-calculator question, you could work out 7 twelfths of 300. So you divide by the bottom and times by the top, and again, you would get 175. So how many odd results should George expect to get if he does this 300 times? The answer should be 175. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on sample space diagrams. I really hope you found this video useful, and if you have found it useful, please like it and please subscribe to the YouTube channel. If you need any extra help on sample space diagrams, if you go to Corbettmaths and go to the videos and worksheets section and go down to video number 246, there's a dedicated video tutorial there on sample space diagrams. Alternatively, you can scan this QR code. But in this video, we focused on the video solutions to the practice questions. Again, I really hope you found it useful, and if you have found it useful, please like it, please subscribe to the YouTube channel, and maybe even recommend it to a friend or to your teacher and so on. Thanks very much. Thank you. Bye.